Hello students. Today we are going to cover the multiplication property of equality. And this is similar to the last two sections that we were just studying, addition and subtraction property of equality. We are going to be looking at an equation, and whatever we do to one side, we still have to do to the other. You will see that as a pattern. It will always stay that way. If you do something to one side, you have to do it to the other so that it will stay equal on both sides. Again, we're going to do an example with just numbers, the same numbers I've been using. 5 equals 5. This is an equation. We don't have any variables in there. And if I multiply, we're going to multiply by 2. If I multiply on one side of the equation and I don't do it on the other side, it's not going to be correct. And if I do it on the other side, if I do multiply both sides by the same amount, we're multiplying both sides by 2, we are going to end up with an equation that is correct. 10 does equal 10. This should seem pretty familiar to you. So we're going to take a look at example 1. X divided by 8 equals 3. So we're looking for some number that when you divide it by 8, it's going to give you 3. So we're going to use our multiplication property for this one because there is division. When we are trying to isolate our variable, when we want to get x by itself, isolate means to get by itself, we need to do the opposite of what is happening to it so that all it's being multiplied by is the number 1. Because if any of the variables are multiplied by 1, we don't usually write that out. 1 is kind of that value that's always hiding around, being multiplied and divided by numbers, but we do not continuously write it everywhere because it's redundant, which means it's repetitive, and we're always trying to find ways to write it the correct way without writing in ones multiplied by everything. So x is being divided by 8. The opposite of dividing by 8 is multiplying. And when I multiply this by 8, 8 divided by 8 is just 1, so they cancel out. If I do multiplication on one side of my equation, I need to do it on the other side as well. And when I'm talking about sides, I am talking about either side of the equal sign. So the left side is the one side and the right side is the other side. So 3 times 8 is 24. Our 8's on this side have canceled out because 8 divided by 8 is 1, and our x drops down. And our final answer is x equals 24. Now it's time to check your work. We need to take our final answer and plug it back in to our original equation, which was x divided by 8 equals 3. So we should know that 24 divided by x gives us 3. That should be a solution if our answer was correct. And 8 does go into 24 3 times. So 3 about that. 3 equals 3 is correct, and when we checked our work, we saw that we got the answer right. All right, now we're going to take a look at example 2. Our variable is t, so we need to solve for t. What is t equal to? Well, we don't know, so we're going to kind of set that off to the side for now. Our equation is some number t divided by 4 is going to give us 5. This might be something where we can just do it in our head, like I have said with the other examples in previous videos. But again, we need to know why we are making the decisions we are making with each step we take. Because when we get into multi-step equations, there's going to be multiple steps to take. And it's harder to do those ones in your head. So t is being divided by 4, and we need to do the opposite of what is happening to it. So we should multiply by 4, because 4 divided by 4 gives us 1, and we have successfully isolated our t. And if I do something on one side of the equation, I have to do the same on the other. We multiply the left side by 4, and now we need to multiply the right side by 4. These 4's cancel out, and the t drops down. 5 times 4 is 20, and so our final answer is t equals 20. And it is now time to check our work. So original equation was t divided by 4, so we're just going to go ahead and put in 20 divided by 4, and that should give us 5. 4 goes into 25 times, and so we know that our answer is correct.